In our previous videos, we handled compound interest. However, now we'll do a special case called continuous interest. The question says that we have an investment amount of $2,000 and we're compounding continuously with an interest rate of 3%. We are asked how much money will be in the account after 5 years. Let's begin by introducing the continuous interest formula. The continuous interest formula says y is equal to p times lowercase e raised to the r times t. In this example, y is still the amount in the account, p is still the principal or initial investment, r is still the rate, and t is still the number of years. For those of you who have not seen lowercase e before, lowercase e is an irrational number. This irrational number is also called Euler's constant. This is an irrational number similar to pi in that it has an endless number of digits. Euler's constant is roughly 2.72. However, you won't need to punch this into your calculator because almost every calculator that you'll use for this course will have a special lowercase e button. Therefore, don't worry too much about memorizing it, but know that it is a constant number. It will never be your unknown. Let's try to figure out what our unknown is for this problem. We're given $2,000 initially. Our initial investment is p, and we'll say p is $2,000. It's compounded continuously. The fact that it's compounded continuously tells us to use the continuous formula, not the original compound interest formula. We're also given the interest rate of 3%, that's R, and we're also given a number of years, that's T. Therefore, we go to our formula, we'll check off P, check off R, and check off T. Our unknown then is the Y. Let's place the numbers that we do know into the formula. We'll have Y equals 2,000 for P multiplied by lowercase e raised to the RT, where R is 0.03 and T is 5. We can go to a calculator and calculate this value. We end up with $2,323.67 if we round to the nearest penny. If you watched our previous video about compound interest, this was almost exactly the same answer. It was a difference of roughly 30 cents. Therefore, compounding continuously versus compounding monthly doesn't make much of a difference, unless you're dealing with very large interest rates or very large amounts of money.